Hi guys, this is Tobias, TL3MHT, and today I'm building a peak hold circuit for an old analog SWR meter. So this is a little dual op amp, let me see the number, LM358. And on the internet I found an old article from, let me have a look, John Fielden, GW4NAH. Which was reprinted 1989. So it's a pretty old circuit, and I don't know if John is still with us or who has the copyright to that article or the schematic. Anyway, this is just my fun Saturday afternoon. So I spent some time to find the parts, and I think I have everything that is needed to build the circuit. I'm only missing one 10 mega ohm resistor, because 10 mega ohm resistors is something that is pretty rarely used. So I put this all into the box, and the first part of the exercise will be to just manually place the components. I have the pin out of the op amp here next to me. Let me just tell you. So this is output. Well, there's two op amps here, one on the left side, one on the right side. This is the ground, this is VCC. This is the output one, input one negative, input one positive, input two positive, input two negative, output two. Okay, so, well, I have the schematic here next to me and do manual routing on the fly, and hopefully we don't need too many wires crisscrossing across. So the first step will be probably a time lapse, just placing the components. Okay, so as you can see, this is a 7 minutes time lapse, and I thought 7 minutes of annoying music is not something you want to listen to, so I just do a voiceover after the fact. So as you can see, I'm starting with the resistor and a capacitor that should connect the left side of the output of the left op amp to the input of the right op amp. And I'm measuring my resistor here, and then I figured out that I picked the wrong one out of the parts box, and I had to swap out the resistor and use the right one. So it's always good to have a LCR meter and do a sanity check before you solder components in. And this will be a quite tight build. Not sure if that was the best idea. I was thinking about making this a SMD component. You know, you can really build this pretty tiny, maybe 2-3 volt coin cells, a small SMD SOT8 op amp, and it could be, I don't know, maybe 2 or 3 centimeter times 1 centimeter big, and then you can easily fit it in your analog SWR meter. Okay, so what are the next parts? Yeah, there's a few diodes. In the meantime, or after the fact, I read the description of the schematic. And, well, it basically is supposed to be hooked. Well, you detach the original analog SWR meter, and the circuit just then goes in the middle. You know, the output wires of your existing SWR meters go to the op amp input, and then the output of the second op amp goes, well, back to your analog SWR meter gauge. So it's designed in a way to represent the same resistance as the original meter, something between 0 and 2.2 kilo ohm. And then you basically, well, then the original SWR meter sees the exact same load as before, but you have your peak hold circuit in the middle. So this thing should have a gain level of 1, obviously. So when there's a certain voltage on the input, you also have it on the output. And the only, trick is basically that it implements the peak hold. So if you have a very short spike here in your SSB transmission, it will basically hold that peak value for, I don't know, depends on the RC values, maybe a second, 2.5 seconds. I don't know, I have to check again. Okay, so as you can see, now we have a few resistors on the left side, and I'm brilliantly out of frame and filming this out of frame. So yeah, I should maybe update my overhead setup, because it's not like one of the pro YouTubers where the camera is like 3 meters away on the ceiling and a very nice macro objective zooms in. It's really basically right in my face when I'm soldering. So it's basically in the way. I can't even properly see the parts. And that's why I always move the PCB towards my face and out of frame. But whenever I remember that there's a camera overhead, I shift it back into place. Okay, so here we go now with the 50K trimmer. That is used to balance the two op-amp inputs so that they get exactly the same bias voltage, I think. And I'm trying to find a place where to put it, and also think about the two remaining trimmers, because now I'm running already a bit out of space. So there's a bit of fiddling and backwards and forwards and thinking where to put the 50K trimmer. But anyway, this is a one-time prototype. And if this would go into production, then you would use something like Design Spark PCB or some other PCB routing program. And then it's, of course, easy to move components around and then at the end have a nice layout that can be produced into a dual-sided PCB. Well, a dual-sided PCB would also have the benefit that you can do a solid ground fill on top, and then you save a lot of hassle in connecting certain components to ground, because you just say, oh, I need a via to the top layer is ground, job done. So no annoying ways to route ground from the left side of the PCB to the right side. You just have one via to the top. So that really simplifies things a lot, and you have to think about these things when you wire things up just with a single-sided PCB. So yeah, I'm apologizing. I'm not very well in frame, or only occasionally in frame. But here you see this is all the bits that I still had in the junk box. And at this point, I realized that I accidentally picked a 200 ohm resistor, and I needed a 200 ohm trimmer. And luckily, I found one in the parts box. And now I'm thinking how I would wire up these two trimmers. Because obviously, when you, have the trimmers turned all the way to the left to minimum, you also want it to have a minimum effect, right? So you don't want to turn left and things increase in volume or in voltage. So okay, I think we're reaching end of part 1. We have everything on board. We are just missing a 10 mega ohm resistor, which goes here somewhere parallel to this 1 microfarad to ground. Apart from that, and the op amp is also fitting on top. No. Okay. Well. Now I want to cut and paste and drag it by 1-2 rows to the right and 1 row up. So somewhere here. Anyway. This was the accidental 200 ohm resistor. Let's double check. We don't really need that one because we needed a 200 ohm potentiometer. So what I will do is throw all the cut-offs into this box. Yeah, maybe not the short one. Maybe only the ones that can be used to wire up the circuit. So the longer ones here, those. This is from the diode, a bit too thick. This is also from the diode, from the 1N4. 004. Yeah. And this one. Okay, I think good enough for the moment. Right. The real miracle is that I found 3 fitting potentiometers in my parts box. 50K, 2K and 200 ohms. I would not have thought it's possible. So I'm only missing one 10 mega ohm resistor. That's pretty good. Okay, time to clean up here. And yeah, maybe let me show you the beautiful build. Well, it's not a build yet, it's just component placement. And from the bottom, there's a bit of work waiting. Okay, so let's start wiring this up and see how it goes. Okay, connecting the components. This part of the video took me 2 hours in real time, and in a time lapse it's still 11.5 minutes. I'm not sure if I will punish you for the whole time. Let me just do some general comments and rambling while you see me, fiddling here and soldering in the parts, the wires one by one. So what I always do is whenever I place a wire, I mark it off on the schematic, because this is a build where I make it up as I go along. So I have not really made the effort and used pen and paper and basically use a gridded paper and drawn down my components and made sure where to place my wires. So I'm making it up on the fly, and of course that can also go wrong. Sometimes you forget that you have to route a wire from a certain place to a certain place, and if you do not check that up front, then you somehow run out of space if you have placed your components too tightly, or if you have run a wire and then you realize, oh, I have to get on the other side of the wire. Of course, you can always put in a jumper from the top, but yeah, this is, as I said, this is the gung-ho hobbyist one-time build. method of doing it. And maybe if you're doing it for the first time, I would really recommend to make a drawing, either pencil and paper, or you use one of the PCB design tools that are available these days. I use DesignSpark PCB, or I have used DesignSpark PCB, and that was mainly because it was easy to design my custom components. Because what I always find really tricky is getting parts with a matching footprint that matches the stuff that I always have already have in my parts box. So I have a lot of old parts inherited from my dad, and God knows what RS component, JLC PCB or PCBWay component number those have. Yeah, I mean, for resistors it's easy. Yeah, there's only so many ways you can place your resistor, so that is still manageable. But if you then have components that are not available in the library and you want to somehow make a PCB design, then you could spend hours in somehow getting in your custom part in your design tool, and that really costs time and is no fun at all and takes the fun out of it. So if you know of a good affordable PCB design tool that makes it very easy, or has a very good component library and makes it also very easy to add your own custom components, I would appreciate a comment below. Okay, and I think I already said earlier that what you could do is, when you design your PCB, you could just use ground fill on the top, so make a dual-sided, two-layer PCB, have all your signals on the bottom, and have a copper ground fill on the top, and then it is very easy to basically connect any part, any signal / any part to ground, because the whole top side of the PCB is ground. So you just add a via and bang, job done. And if you're routing here in my gung-ho, make it up while I go a long way, then you have to keep in mind that, oh, hang on, here on the top left, I need ground, and on the bottom right, I need ground, and somehow I have to get those two pins connected in the end. So that's why I built it in 3 parts, and the third part of the video is really just dealing with the ground connection. So yeah, my soldering style, and so it's not really super pretty, and sometimes I mess up or things move around, and then you have to use the solder wig, like here, to wig stuff off. But I find it pretty relaxing, I must say. So as you can see, yeah, now you have a little bit of the schematic in frame. Whenever I place a wire here, I mark it off on the PCB so that I don't forget anything. And the same at the end with the ground connections that use the PCB ground symbol, so that I can be sure that everything is connected. Okay, I don't know. We have another 5 minutes to go. I think I should maybe make a cut here at maybe 5:30, and we'll jump ahead to the end, and then you don't have to endure the remaining boring build process. Okay, so that was session number 2. Just interim clean up here. I think I ran out of useful bits of cut-offs, so I would just leave those out of frame. Right, so I will just save those few, and the rest goes into the bin. There you go. And bit of interim clean up. You can't see it. Not everything's in frame, but there's another cut off. Right. Okay. Not too bad. That was now almost 2 hours. Not sure how I will cut that into a video, but maybe show you, well, the top you've already seen. And the bottom, well, of course it has to, I've run out of alcohol. I need to buy another 5 liters of IPA. Not sure if I still have contact cleaner somewhere to clean it off. Okay, so this is session number 3 or 4 if you also count finding all the parts out of the parts box. So now it's setting up the remaining ground connection. Okay, so as I already said, the remaining ground connection is missing. So here I'm adding the first jumper that I needed to get ground from one side to the other. And I think later I am adding another one, or right now, not sure. Yeah, right now. Because the placement of that 47 or 10 microfarad capacitor there on the top was really unlucky. So in hindsight, it should have gone somewhere else. And that's why I need another jumper. So I think here I'm wiring up the input. So in the end, by accident, all the connections ended up on the right side of the PCB. So the input and output to the analog meter and the power supply, everything ends up on one side. Most likely because that's the only side where I still had space on that PCB. Yeah, I think I still could cut it by 2 rows, but I will first test if it works, and then we can always use a small saw to cut it shorter. So not sure how long this ground connection wiring up took. That I think it also took maybe an hour or so. And now I'm wiring the ground for this adjustment potentiometers. And as you can see, that's already late in the evening, so my white balance is shifting towards blue because I didn't reset the white balance when I started filming the last part. Yeah, and here I realized I had adding markers next to my flux pen, and I was already seeing myself painting the PCB instead of using the flux pen because they all have the same size or very similar size. So in the end, I put the adding the black markers into the marker box far away from the flux pen. Yeah, and that connection made some real problems. I used some old wire, copper wire, and it really did not take the solder, and I think I took it. Yeah, I'm frying around here like the last idiot, sorry. So I'm trying to get it to accept the solder, but it doesn't. And I think in the end I give up and replace it again. And yeah, here I try to clean my solder tip in the hope that it helps, but it didn't. So I think I gave up and I removed that wire once more and used a cutoff of a resistor because the copper wire would not wick yeah, there I was at the parts box and stealing an end from a resistor. And then I switched on the light because I couldn't see. But in the end, I got it there. That's the fun part. The last wire took really ages to put into place. And yeah, I think this is just final touch up. And we are as good as done. So double check that all the ground connections are actually connected. And that was session number 3. Okay, so that was a weekend build, and we don't know if it works because we still missed a resistor. And then we can clean it off, double check the schematic. Just cleaning up here a bit in parallel. Switch off the soldering iron, and we are done for this weekend.